Hello friends, very good afternoon. Myself Dr. M.H. Annaya, and in today's video we are going to work out a problem on an eccentrically loaded welded joint. So the question for today runs like this. There is a plate and this is welded to a vertical column by means of this C-shaped welding, and they are asking us to find out what should be the size of the weld. Okay, so friends, basically the design procedure followed for this eccentrically loaded welded joint is exactly similar to the one we do for the eccentrically loaded riveted joint. Friends, here you can just see the welding having width 120 millimeter, depth 240 is subjected to a load of 35 kilonewton, and they have given all the distances, and we have been asked to find out what is the size of weld required to take up this load or to withstand this load. Basically friends, this involves around 4 steps to solve this problem. And in the first step friends, I am going to locate the center of gravity of this welding done. So in step number 1, we find out what is called location of location of CG, and calculation of eccentricity, calculation of E. E means eccentricity. I will tell you what it is. Friends, if you observe this welding is eccentrically loaded because the center of gravity of this is somewhere here G. I will tell you how to find out it. And the load is acting here. So there is an eccentricity which is defined as a distance between the load line and the center of gravity. This I will tell you how to find out. So to locate CG is nothing but finding out x bar comma y bar for this with reference to the this vertical line. Friends, here since this welding is symmetrical about this horizontal axis xx, horizontal axis, what we do? We can write down directly the value of y bar. Y bar is equal to half the depth, that is y bar is equal to 240 by 2. So y bar is equal to 240 by 2. That is depth by 2. This depth by 2 because of the symmetry. Because of symmetry. Because of symmetry in welding. So that is 120 millimeter. Friend, on the same lines, what is x bar? Friends, x bar is the distance measured from this y-axis, the left end, to the CG. Friends, here in the books, they have called this distance as CY. That is given by 2b, b square divided by 2 plus. This is b square divided by 2b plus d. This is given in machine design handbook. Under this welding chapter, they have given this. Friends, here we know this B width is 120 mm square divided by 2B, 2 times 120 plus the depth of that is 240. And if you simplify friends, this works out to 30 millimeter. So we have got the value of x bar, we have got the value of y bar, and friends, the term eccentricity is the distance from the load axis to G. So this is eccentricity. And friends, very obviously, this distance is equal to total from here to here is how much? 600 minus this 30. We got just now. This is 30. So this will be the value, that is 600 minus 30 is 570. So I will just write down here the eccentricity E is equal to total, that is 600 minus Cy. 600 minus Cy is 30. That is going to be 570 millimeter. It is the distance between the load axis and CG. Friends, in the second step, step number 2, we will calculate what are the direct and shear loads acting. So in step number 2, let's find out what is step 2. We will find out what is called the direct load. The direct load we will represent by PD, P suffix D. So direct load is given by the total load P divided by length of weld. Length of weld. Friends, what is the load given here? The load is 35 kilonewton. 35 into 10 to the power of 3 Newton divided by length of weld is B plus D plus B. So B plus, or you can say L is equal to B plus D plus B. That is B is 120 plus 240 plus 120. This works out to 480 mm. So I am going to substitute here. And friends, you get this value of PD as 72.12. 72.12 is the answer. 72.12. It is Newton per mm because the load is in Newton, the distance is in millimeter. That is the value of PD. Friends, now next arises the question, where does this load PD act? Friends, in any of such eccentrically loaded welded joint, the value of this PD or this load PD acts at farthest end of the welding. For example, if you take up this weld, friends, we have the CG here and the farthest ends are either A or B. So you can take either this A or B as the farthest end, and I am going to show the distance as small r, and here it is going to act at this point A. Let's say it is acting at A. How does it act? This load PD acts at this point A, the farthest end, parallel to the applied load P and in the direction of it. So friends, very obviously it has to act downward because P is acting downward and its value we have called already here. Simply I'll mark it as PD, P direct. So this is parallel to the applied load and in the direction. In the direction means both are acting downwards. Parallel means the distance between these two is a perpendicular distance. So friends, we have calculated what is the value of the direct load. Friends, next comes calculation of the secondary load. That is the load due to this eccentricity, and that is given by the formula secondary load. PS is secondary load due to eccentricity in loading. Eccentricity in loading. That is given by the formula P into E into R by JW. PR. This is again available in the machine design handbook under this chapter, design of welded joints. Friends, here we know the value of P. P is the load that is be specified in the problem, and it is 35 into 10 to the power of 3 Newton, this value, 35 kilonewton. E is eccentricity we have calculated as 570. That is the total distance from P to here. 480 plus 120 is 600 minus 30 is that value of Cy, and this is how we get the value 550 millimeter. Next comes friends R. R is the distance of the farthest end, that is A, the distance GA. How to calculate GA friends? Friends, we know this value. This is 120 minus 30. This is 90 and this is 120. So this is 90 and this is 120. Square root of 90 square plus 120 square, that is equal to the value of R works out to 150 millimeter, 150 mm. So we know P, we know E, we know R, and this JW is given by the formula JW equal to the polar moment of inertia is 2B plus D whole square by 12 minus B square into B plus D divided by 2B plus D. Friends, this formula is again available in MDH. This because this big formula one cannot remember, and that's the advantage of using a machine design data handbook. So friends, we know the value of B, that is 120 mm. The value of D, the depth or the height, is 240 mm, and we can arrive at the value of JW as 6328 into 10 to the power of 3. 6328 into 10 to the power of 3. Friends, this is going to be so many mm to the power of C to the power of 4. This is B and D dimension square by 12. Okay, millimeter square. So millimeter cube you will get the value of JW. Friends, finally, we know all the 4 parameters, namely P, E, R and JW, and we can find out what is the secondary load PS as a value equal to 561.66. 561.66 is again Newton per millimeter. We have the direct load and now we have calculated the secondary load. Next arises the question, how does this load act and where does it act? Friends, this load PS acts normal to R, normal to GA and at A. So at A and normal to GA, so as to produce a similar moment as that produced by P. Friends, about G, P is producing a clockwise moment. So also PS acting here perpendicular to that should produce a clockwise moment, and this I will call it as PS. We know the value. Friends, now PD is the direct load, PS is the secondary load, and it will be acting at this point A. And next comes the calculation of the resultant of these two loads. Say step number 3, we are going to calculate what is the resultant load. So, friends, if you have got two forces, P and Q, acting at an angle theta, you know the resultant of these two, that is given by the resultant is P square plus Q square plus 2PQ cos theta, where theta is the angle between these two. Now, if I want to find out the resultant of these two, I have to complete this parallelogram. and this diagonal will give you the resultant. This is our P resultant, or the resultant of PD and PS. Friends, how to find out? Now we have the formula in terms of PD and PS to get the value of the resultant load. So we can just write down the resultant load PR is equal to square root of PD square plus PS square secondary load plus 2 times PD PS into cos theta. It is a simple formula and we use it in high school. It's also this formula. Friends, we know PD, we know PS, and we have to find out this cos theta. What is that theta? As I told you before, it's the angle between these two. That is same as this because of simple geometrical relations. This angle theta is equal to this angle. So friends, how to find out that, friend? We want cos theta in the formula. So what I do, from this triangle GA, say K, from this triangle GAK, cos theta equal to GK, adjacent side, divided by GA. So from triangle GAK, from this triangle, right angle triangle, we have cos theta is equal to GK by GA. So that's equal to, what is GK? GK, this is 120 minus 30, that is 90 millimeter, divided by GA is that radius R, that is 90 divided by, and the radius we have found out as 150. 90 divided by 150. I think you will get cos theta equal to, therefore cos theta, if you simplify, it works out to 0.6. Friends, we know all the values of PD, PS, cos theta. You can substitute and find out the value of the resultant load PR. And this PR works out to, PR is 608.22. 608.22, and the units of this are again Newton per mm. So you have calculated up to finding out the resultant load. And friends, once you have the resultant load, the permissible shear stress for the weld material is given to you as 90, and we are required to find out the finally the size of weld. So step number 5 and the last step is to find size of weld, which is generally represented by H. So what do we do here, friends? We get H by equating tau to PR divided by 0.707 into H. So resultant load PR, and this is the throat thickness 0.707 H. So friends, I am going to equate that now. Therefore shear stress is 90, that is given by resultant value 608.22 and divided by 0.707 H. Friends, here only H is unknown and the value of H works out to 10 mm. So this is the size of weld required in this joint to withstand the load of 35 kilonewton. Friends, I hope the presentation was interesting. Please go through the complete video, and if you find this interesting and is of some benefit to you, do share with all your friends without fail. Thank you, friends, for watching my YouTube video. Have a nice day.